Let's try to find outliers for this data. See, to find outliers, I need to calculate the quartiles first. So, in order to calculate the quartiles, I also need to arrange them first. So I'm going to arrange them like that. Smallest value is 1, and then 3, and then 9, and then 21. And to calculate the quartiles, I need to divide the data into two groups. So this is the first group, and this is the second group. The median for this data is here, and that's actually Q2. So between 3 and 9, the average, if you add them and divide by 2, it will be 6. And Q1 will be the average of these two values, which is 2. And also Q3 will be the average of these two values, which is 15. Okay, I got the quartiles. Next step is to calculate the interquartile range, IQR. See, IQR is Q3 minus Q1. So Q3 is 15, and then Q1 is 2, so that gives me 13. Okay, and then what is outliers? Outliers are extremely high values, extremely low values that are existing in the data. So the question is 21 extremely high value? Is it considered outlier? Is it too small? Is it considered outlier? That's the question. So to do that, we need to calculate some measures. So that's the upper fence and the lower fence. So let's do that. The lower fence is simply Q1 minus 1.5 IQR. And in this case, what Q1 is equal to 2, 1.5 should be multiplied first by IQR, which is 13, because multiplication should happen before subtraction. So in this case, this is equal to what? That's equal to 2 minus, let's do that, 13 times 1.5 equal 19.5. Okay, so I have here 19.5, and that means minus 17.5, negative 17.5. That's the lower fence. Okay, the upper fence, Q3 plus 1.5 IQR, that's the upper fence. Okay, so in this case, this will be Q3 is 15 plus 1.5 IQR, which we just got now, that's 19.5. So that will give me, how much this? 34.5. Okay, so the lower fence is minus 17.5, and the upper fence is 34.5. By the way, these are not the outliers. These are the lower and upper fence that will help me decide what are the outliers. So how am I going to decide that? Okay, I'll just graph approximately the range of the data. So I have here the minimum value is 1. Okay, so approximately that's 1 here, right? So the minimum value is 1, and the maximum value in the data is 21. And let me also graph the, so this is my data now. My data is from 1 to 21. That's my data. And let's graph also approximately where are the fences. The lower fence is here. It's smaller than 1. That's minus 17.5. And the upper fence is here. It's actually higher than the maximum value, which is 34.5. In this case, if this is the fence and the data is inside the fence, that means all the data are good. There is no outliers in this case. There is no outlier. Okay, why there's no outlier? Because all the data from 1 to 21, all of them are inside the fence. This is my fence here. Okay, this is, imagine this is my fence. Okay, so this is my fence of good data, and in this case we can think of this to be my data here from here to here. So all the data are inside the fence, and that's why there is no outlier. Let us see another example where some of the data are outside the fence. In this case, this part that is outside from this side or from this side will be considered outlier. Let us find outliers for this data. Here I have how many values? I have 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, remember the first step, I need to calculate the quartiles, and to do that I need to arrange the data. So here I'm arranging the data and then calculating the quartiles. I think you can do that. Once you calculate the quartiles, what's the next step? I need to find IQR. IQR is Q3 minus Q1. So let's find IQR, that's 11. And then I need to calculate the upper and the lower fence boundaries. And in this case, I need 1.5 IQR, because 1.5 IQR is part of the formula for calculation of the fence. So I need to multiply that by 1.5, which is 16.5. Then I will use it to calculate the upper fence boundary, which is Q3 plus 1.5 IQR. That's Q3 is equal to 20, and 1.5 IQR is 16.5. So I just add them, that gives me 36.5. So that's the upper fence. Remember, the upper fence is where should encapsulate all the data from the high end. So in this case, if you look at the data, what do I have here? I have 50. 50 is already a higher value than 36.5. So some of the data is actually outside the fence. So that means 50 is outlier. Why? Because it's higher. 50 is a value in the data that's actually higher than the upper, boundary of the fence. Okay, that's coming from the formula. So 36.5 is not the outlier, but 50 in fact is outlier. Let's look at the other end, which is the lower boundary of the fence. We need to calculate Q1 minus 1.5 IQR. So that is, okay, of course, 50 is outlier. And let's calculate now Q1 minus 1.5 IQR. Okay, Q1, of course, is 9, and 1.5 IQR is 16.5. So if you subtract them, you get minus 7.5, which is a value that's way too small compared to the minimum value in the data. The minimum value in the data is 5, which is actually bigger than minus 7.5, so it's actually inside the fence. 5 is inside the fence, 6 is inside the fence, 12, 13, 15, all of them are inside except for the 50. 50 is actually outside. Okay, so that's why the only outlier I have is 50. Okay, look at this quick demo of where the data is and where the fence is. Now the data is from 5 to 50, and the fence is from minus 7.5 to 36.5. As you can see, some of the data are outside the fence. See, the data should be all inside the fence. Like here, this house is actually inside the fence. Some people don't know what a fence is. Okay, that's an example of a fence surrounding the house, where all the house should be inside this fence. Same thing here, the data should be inside this fence. But when some part of the data is outside the fence, like in this case the 50, then the 50 is called outlier.